So analyze of variance. So analyze of variance is short form is ANOVA, analyze of variance is one way. Here one way actually means ANOVA actually means try to see if the grouping would make a difference, right? Suppose we have male and female, whether this would make a difference, or whether people live in three different areas, right? Area A, area B, area C, if to see the grouping by itself, there's a difference between the mean between different group. Okay, so idea is we have group data, and the fact or the factor means the same group. Okay, and that will be each x, right, variable and its group factor. So data point would be data point one, observation one. I know his group, right? Maybe this is marks. This is area one. Maybe income area one, income area and area, income area, right? So in this context, x1 is in g1 and x2 in g2. Okay, and there's a C groups. Okay, the final number group C. Of course, C is less than n. And alternatively, you can write in this way, right? You can as x11, right? Means observation one of group one, x group one, okay, and observation n1, and so on and so forth, right? So that means you write in this way means x1 has observation 1 to n, group C will have observation 1 to nc. So each group have observation ni. So that's the way we write in this way. So you can also represent the data in the table form. Usually this is what you see in a spreadsheet. Group 1 will be 1 up to n1, group 2 will be 1 up to n2, group n will be 1 up to nc. So this is the way. So what we are trying to do is to see the mean of each group, okay? Are they the same or different, right? Try to see the grouping would be meaningful, or the group would be different, right? So you can, the basic thing is like the treatment 1, treatment 2, right? There's a lot of experiment can be done here. So there's a classical linear model, okay, will be the observation xij, right? Group I observation j is group its own mean mu I, and there's some error, normal random error, epsilon ij, okay, and also we will have what we further write the group, each group mean mu I will be the overall mean, the grand mean, okay, and usually we call this treatment effect, right? Because each group is treatment, and sum of all the treatment will be 0. Okay, so that is the classical people will write in this way, and the question is, are the mean of all the group are the same? So the mu1 is group 1 and group C, right? The same. So this is the group is the same. Alternatively, is any treatment effect, because each group, the mean is mu I is different from the grand mean by the treatment effect, right? So ask the treatment effect, are there any treatment effects, right? So why we care about it? Because suppose the patients, right, whether the medicine, different medicine, whether they recover faster, and different customer or different countries different, or marketing schemes, or different products, how do they, the profit they make. So what they do is variance comparison for the f-test, okay, because if you assume the same mean, the variance cannot be too different, right? I mean, if you assume the same mean, but if they're not, then they will be a lot of different. So that's the idea. So we have to define in the analyzed variance, often we have SS what, FST, SS W, and SSG and SST, right? So this is the things behind. So SST is the total variation, okay? Total variation is referred to each observation and overall mean, the grand mean, x bar. X bar is overall mean. So basically sum of all observation divided by n, okay? So look at each observation and the mean and square. So basically this is a sum of all square of from the grand mean. Okay. And now we consider between group variation. So we do the same, but now we replace each observation by its group mean. So x bar I is the within group is the mean. Okay, so that is x bar I. So basically that's why each group the same, so that's why we can replace the summation by ni here. So this is within group estimation. So actually it's also sum of observation or the deviation, but it's deviation of its group. So each group observation minus not the global mean, the grand mean, but the mean of its own group, right? Within own group, what's the difference? So using this SST, SSG, and SSW, we can conduct F test, okay? And as we see the F test, we will divide the mean. We call MST, MSG, and MSW. Is divide how many grouping of them, right? Because overall the n observation, so n minus 1, right? With no degree of freedom, with minus 1. So MSG is a group with CML group, but minus 1. Okay. And same as within group estimation is variation, okay? And also is n minus c. Okay, so F test said the mean of different group is different, right? So the null is all the same, alternative is not all equal. So as long as there will not one not equal, then it's fine. Okay, we're not checking which one is not the same, but the simplest case we just check they're not equal. So it's MSG over MSW, so it's SSG over SSW, C minus 1, N minus C, so it's a standard F statistics here. Okay, C minus 1, N minus C. So why this is the case? So under ANOVA, every observation has followed the normal distribution with its own group mean, right, and common variance, okay? And the sample variance of each group is defined in this way, right? It's like SI, MISI, right? Is XIJ minus XI, okay? And under the null, right, SI would estimate sigma, right? So if we combine all different sample of each group, right? So basically to pool it, because each one is independent, right? So that's why you can sum up every group, right? Is divided by N minus C. Okay, it's SSW over N minus C. And then, because we know this is independent, so this is the chi-square distribution. Okay, so that's why this SSW over sigma, okay, will be chi-square N minus C. Okay, and then similarly under the null, SSG is also a chi-square C minus 1. Okay, so that's why they both are chi-square distribution. That's why they follow the math. Okay, thank you.